So we're given a function, okay? We want to know the derivative of that function. In other words, we want to know the instantaneous rate of change at a given point. Then by definition, that's the limit as h approaches 0 of the function x, this function here, of x plus h minus this function here of x all over h, but a gradient which equals the change in y over the change in x. So if we look at our graph, the graph looks like this. We decided to make one shape like that. If we said, here's the point that we want the instantaneous rate of change at. Here's a point that equals x. Here's a point that equals x plus h. So at x, y equals f of x. At h plus x, y equals f of x plus h. So what we can do is we can find an average rate of change by measuring the gradient that joins these 2 points, and that gives us an average rate of change. So that would be the change of y being, change of y is the final value of y minus the original value of y. So the final value of y is the function of x plus h, because that's what you put into the function and you get that value of y. And you subtract from the original value of y, which is the function of x. Put x in, that's what you get. So, but it's all over the change in x. Well, what's the change in x here? The difference between x plus h minus x, x plus h minus x, well, that equals h, obviously. So we can just do this bit. That's what we have in the top. That's our change in y. Down the bottom, our change is h. So that gives us a gradient. It gives us a rate of change. But if we want the instantaneous rate of change at this point, what we're after is this thing. That's the instantaneous rate of change. So how do you get that? How do you get that gradient of the tangent? This one here. The gradient of this tangent line is this. So if we take a look at this graph here, let's take a closer look at this graph. As these 2 points come closer and closer together, so if we take an x value which is closer to this one that we want, and we take an x value here that's close to this one we want, we get a line which is closer and closer to being this tangent. So that's why we use the definition of the derivative. The definition of the derivative being the limit as h approaches 0 of f of x plus h, because that's our final value of y, minus the function of x, that's our original value of y. So the final value minus the original value equals the change in y over h. This is the change in x, because we have the final value of x being x plus h minus the original value, which equals x. So x plus h minus x equals h. So that's how we got the h at the bottom. And the limit is because we bring those 2 points together closer and closer and closer and closer until h almost equals 0. But we can't just substitute 0 in there, because then we'll have a problem where we've got 0 in the denominator, not good, or we've got f of x minus f of x, which gives us just 0, so that's not going to tell us anything about the gradient. So if we do it this way, that's how we find out that instantaneous rate of change.